times minus 1296, get an answer dividing it by 17. And in this case, I've got an answer of 276.515. 276.5159882. And this would be Newton per meters. Newtons per meter. Okay. Now, I've worked out the length, I've worked out the UDL. The magnitude of the maximum beam deflection, delta max. So, this is where I was testing if you had actually studied. Question is asking for the magnitude of the maximum beam deflection. So, there's a beam, it's being deflected. I want to work out the maximum value. How do I do that? Well, I've already worked out the beam deflection equation. So I could actually cheat and take it from the textbook, or I could work it out. So let's just work it out. We have EI V is equal to minus 1/2 MA x squared minus 1 over 24 qx to the 4th plus 1 over 6th 1/2 q L plus MA over L x cubed. We just divide through by 1 over EI. Okay, so we've got all of that. We're just going to put in the information. So, according to the question is giving EI is 1.04 10 to the 4. So we're just going to divide through by that. 0.400324 times 10 to the 4 minus 1 over 2 MA 24.207, all of that stuff. So 207 just going to read this carefully. 265.24 MA x squared minus 1 over 24 Q, which I've worked out as 276.515.9882 x to the 4th plus 1 over 6 into 1/2 Q 276.515.9882 into L, which we have already worked out as 0.83, 0.83.686.9489. What is this? Plus MA, which is 24.207, 26524 divided by 0.83.686 9489, close the brackets, x cubed, close the brackets. Okay, then just use the calculator. So this is why I was telling students, just make your life easy, use an Excel spreadsheet or a programmable calculator, and it'll be quick and easy. So I've been doing the entire thing by hand, but it's not entirely necessary to do everything by hand. So if you were paying attention, you could have done everything on a computer, and I'll show you a quick way we could have done this without doing all of these hand calculations. So all of these hand calculations, if you're a little bit fast and you weren't explaining things, you could have probably done the test in about 45 minutes. It's a bit getting closer to an hour because I've been explaining everything. But if I didn't explain in a videotape, I could probably do the entire thing in 45 minutes flat if I had studied for the test and I had looked for the formulas in the textbook. I'll show you at the end of the video how you could have done the formulas. But anyway, let's substitute everything and see where we go with it. So again, nothing fancy. I'm just going to use the calculator and do everything. So I've got a power of x squared, x to the 4th, and all of that stuff into an x cubed. So I'm just going to write down everything in terms of x squared, x to the 4th, and x cubed, and I won't go through all the details. I'm actually going to use the calculator right now. So 24.20726524 times minus 0.5, get an answer, divided by that, dividing by 1.0400324 exponent form, get an answer of minus 1.16 and change. So this is minus 1.163774573 times 10 to the minus 3 x squared. It's one term. Then we do the x to the 4th term. So that would be 276.515.9882 divided by minus 24 is an answer. Then divide that by that, divide by 1.0400324 exponent 4, get another answer, that is to the 4th power, so plus minus 1.107801979 times 10 to the minus 3 x to the 4th power. Now we just work out the terms for the cubed power, which is all of this stuff, 1/6 into 1/2 QL plus MA over that. So using just a pocket calculator, MA divided by L, get an answer, plus open bracket 1/2 times Q times L times that, close bracket equals 2 divided by 6, get an answer, then divided by that. If you're using a non-programmable and old-fashioned calculator, you can do it like that. So let's just do it. So MA is 24.20726 divided by the length, which is 0.836 0.83686 9489 get an answer, plus open bracket 0.5 times q, which is 276.515, 9882, times the length again, times 0.83686, 9489, close the bracket, get an answer, which is this, divided by 6, divide by 6, get an answer, which is that, then divided by this 1.04, then divide by 1.04, 0.0324, exponent 4, get an answer, 2 point whatever x cubed, plus 2.31771419 times 10 to the minus 3 x cubed. Okay, so this is page 2. Let's go to page 3. Okay, so we've already worked out V, which is all of that stuff. So let's write it down. V is equal to, open brackets, minus 1.163774573 times 10 to the minus 3 x squared, plus open bracket, minus 1.10780179 times 10 to the minus 3 x fourth, plus 2.31771419 times 10 to the minus 3 x cubed. All right, what is the question asking? Question is asking the magnitude of maximum beam deflection. This is the beam deflection. Magnitude of the beam deflection. Take the derivative, equate it to 0. dv dx is equal to 2 times that x. So that is going to be 2 times minus 1.163777457 exponent minus 3, which is that answer. So that would be minus 2.32754914 times 10 to the minus 3 x, derivative of the other thing, 4 times that x cubed, plus 4 times minus 1.7801979 exponent minus 3, which is giving me that answer. Plus 3 times that x squared, 3 times 2.31771419, 3 times 2.31771419 exponent minus 3, which is that value. 6.95314.257 times 10 to the minus 3 x squared. Now, what do we do after this? Well, you could solve it directly. So I've done the entire thing from first principles, but the point I'm making is you didn't have to do the entire thing from first principles. If you look at your textbook, Mechanics of Materials, and if you go to example 1, example 1 has already been solved for you. So if you had studied, you didn't actually have to do the entire thing from scratch, because it does the entire free bodies and everything, but it used a different approach. It was using the redundant as one of the reactions. In the question I asked you to use the redundant as the bending moment. But it's not a big deal, because this is how you would solve everything. You would do the same approach, and after you had done the analysis, the problem gave you formulas for the deflection and the slope, and the textbook actually solved the entire thing for the maximum deflection, the angle, and the gradient. So for angle theta b, QL cubed over EI, you had already worked out QL, just put it in the formula. The delta 0, 0.00 QL EI, which is F, just put it in the formula. The delta max, just put it in the formula. So you didn't actually have to solve everything. You just had to look through your textbook, find the answer, and you're good to go. So that's why I specifically chose the problem as you see here. All you had to do is look at the textbook and follow the formulas, and you would have solved the entire question. So having said that, what exactly did you need to solve before you could use the formulas? Okay, so I went through a long story. All you had to do to solve the entire problem was to work out one page, theta is equal to that. This is one page of calculations. So the entire test was literally one page of calculations. Do all of the calculations on one page, literally one page, get to that formula, and then fill in the rest of the formulas. And then you would have solved the entire thing in less than an hour. And I've talked about the explanations and everything. So that was the test. Get to that. Theta is minus 17 over 1296. Let's just write it down. Summarizing everything. Summary. Theta is equal to minus 17 over 1296 QL cubed over F. One page calculations, literally one page of calculations, and then you would look at your textbook, and the textbook would then give you the other formulas. So for the example in 10.1, I'm just going to find it again. The textbook had already given you the results for the reaction. The reaction force is 5/8 QL. The reaction B is 3/8 QL. The reaction moment is 1/8 QL squared. And then the textbook had given you the final results. Delta max is equal to 0.00541/6 QL to the fourth over EI delta 0 is equal to 0.002441 QL to the fourth over EI, and theta B is equal to QL cubed over 48 EI. Okay, so let's look at what the question asked you to do. The question asked you, it gave you a long story about a beam and a UDL and all of that stuff. Okay, fine. If you had looked at your textbook, literally, it's the solve problem from the textbook. All you had to do was look at example 10.1. That's it. Example 10.1. After you had looked at example 10.1, just follow the equations, use the statical redundant, and get to the value theta is equal to minus 17 over 1296 QL cubed over F. And that will give you the value of theta. Use the textbook formula, which is in the textbook. And then follow the rest of it. How would you do it? To work out the length, you would use the value of theta, which is given, the value for F and Q, and then you could work out the length, L. I showed you how to do that. You would just rearrange the equations. And then once you've got the length, L, which we worked out, I showed you how to work that out. In terms of the value for MA, you've got the length L. You would then work out the value for Q over there. And then after you've got the value for Q and L, EI is given, just put it in, you've got the answer. Put it in, you've got the answer, put it in, you've got the answer. And then that solves the entire problem in 1 hour. All right, students, all the best, and just think about how you can calculate things and make your life easier. I will talk in another video on how you can use Excel spreadsheets or programmable calculators. So this has been 1 hour for the entire test, but you could have made your work a lot easier and quicker if you had used just the formulas from the textbook and either a programmable calculator or a laptop with an Excel spreadsheet. But this is where we end the video in 1 hour. Keep well, all the best, bye.